good. Alright, hey guys, so we're going to start off with this NS2 simulation that we have. The first thing we're going to be showing you is so our project is about TCP and mobility affecting mobile ad hoc networks. The first demonstration we're going to show you is the Gauss-Markov TCP model. Here's some notes that I took. So in our presentation, we have a 35 node grid across many nodes. So what we want to pay attention to in this simulation are these nodes over to the left that are going to start communicating with each other. You can slow it down and you can see data going between node 3 and node 22. Play that again. So you can see they're communicating, and as time continues, if they break apart, then they'll stop communicating. And that was our problem with the range. But you can see they're making an ad hoc network and deciding how to transmit data best. That was the Gauss-Markov model, and you can see that they're moving in a Gauss-Markov motion. The next model we want to show you guys is when we did the Manhattan grid mobility model. So this is similar. Again, we're going to look at nodes 31 and 4, which are located in the middle. There we go. So we're going to look in this region. So let's hit play and make it go a little bit faster. You can see the Manhattan grid, they're moving along these XY coordinates, and then once they get close enough, this will create an ad hoc network connection, and then it'll start sending packets. It'll reroute automatically, and there you go. So our project was to use these two different mobility models with a bunch of different TCP models. From this, we got results, and we're going to show you the results in comparison to the research paper that we worked on. So, in their project, they used TCP Reno, Santa Cruz, an ad hoc network, and a proposed method. In ours, we used Reno, Tahoe, New Reno, and Vegas. Vegas is most closely related to ADTCP, and the New Reno kind of simulates the proposed TCP in Santa Cruz, but the proposed TCP uses elements of both. So if we look here, we can see that the delay for Tahoe, Reno, and New Reno are similar. They are around 0 to 500 milliseconds, but if we go down to the Vegas, we can see that there's almost no delay until the very end with weird things happening. The throughput, we can see that the throughput for the three different TC models is also similar, but for Vegas, you can see there are less spikes at the bottom, leading to a higher average throughput. We also want to show you the Manhattan grid model and how it differs. So here we have a lot of delay initially, and we didn't get it for a while in Manhattan grid, and as you saw, that was just the difference in the mobility and if there was actually the mobile nodes to connect to each other. Overall, we have results that are similar to theirs. So again, we were talking about here, Reno and Santa Cruz have similar lower throughputs, and the ADTCP has a higher throughput, and then the proposed is one step above that. So with the proposed TCP, they used stuff from Reno and stuff from Vegas, so we think if they combine those together, of course, they'd get a higher throughput rating. That is our wireless networks project. Hope you enjoyed it.